Hi, this will be a step-by-step tutorial how to build your battery pack using a BMS. So few words about BMS. BMS Battery Management System, in order to protect your cells and to protect your device from overcurrent and things that will damage the battery or can damage your device. So the difference between the BMS is of course the number of cells that you are going to use, the current out. For example, you can see this one is 40 amp, this one is 35 amp. I think some of them support lithium batteries, some of them support lithium phosphate batteries. Of course, the difference is the voltage between the cells, so the BMS should match your cells voltage. You have some smart BMS, you can see my previous video, and in some of them you can change between lithium phosphate and lithium. Lithium phosphate full charge is 3.7 volt. Regular lithium or many kinds of lithium full charge is 4.2 volts. And also you want to make sure that of course your cells can support the BMS. For example, if this is 40 amps, so you must know of course that the cells that you are building can support such a high current out, because if they don't, so the BMS will not be able to protect and your cells can catch fire and it will be like a short. So you have to match your cells to your BMS and to your application. So again, some of the BMS support two kinds of the cells and some of them support just one kind, and some can be programmed and this can be changed. So you have many kinds of cells, and the cells should be able to get the desired current out and voltage out, and then we will connect everything and see that it is working. Few other things that you will need of course the cells. You might want to use an XT connector or a battery connector that can handle the current that should be out, and you want to use this heat shrink to pack all the battery when it is fully ready, and we will go step by step and see how to do everything. So I want to use a pack of total 8 cells, and I want to use 4 connected in serial, and each cell will be consist of 2 cells. So I have 2 in parallel, and again another 2 in parallel, another 2, and I will connect between them using this 4S BMS. And I want it to be a flat pack, so I will take apart all the cells here that I have, and then I will connect everything. I will weld everything with welder to be more professional, and now I will disconnect it from the case and then continue. Now, after splitting the cells, I use this Dremel in order to cut all the metal parts that left after splitting between the cells. So it should look nice and clean after you do it, and make sure that you know which cells were in parallel, because you want to connect the same cell because they have the same voltage. You don't want to connect in parallel cells with different voltage, so make sure to check it very carefully. So before connecting your cell, make sure that the cell voltage is equal between the cells that you are going to connect together. So you see, we can see that the cell voltage is exactly the same because they were in parallel. And we can see that there is a difference between some of the cells in the total pack, so I will have to balance everything. And I can do it after connecting or can do it before connecting. In this way I will do it after welding everything, then I will do all the balancing. You should use protective glasses to protect your eyes from things that might be jump out during the welding. So I'm using these cells and I'm using this nickel strip. You have to cut it to the proper length using regular scissors, nothing special about it. And I'm cutting and starting to weld in a second. So this is the plus of both two. It will go to the minus of the second two. So meanwhile I can maybe disconnect the other cells, and I like to use a magnet in order to catch it during the first welding. It's more convenient to work this way. And now I'm using this big welder, which is a very good one, and doing a very nice welding. Once it is already started, you can remove the magnet and go to the second welding point. Now I like to do at least 2 points of weld. You can see it's very strong. I will reduce the number to 40. And now I can connect these two. By the way, they need to be in parallel to the next two that are also in parallel. So I will use here the next two. Try to remove it. I want them all to be near each other. So something like this. And continuing. Now it's very nice, you can see, very nice welding. Now we will continue and try to install it like this, if I can, and not to forget what is connected to what, and very careful not to do any short. Okay, so there is my nickel strip. So continuing, so this side is already connected. So now I need to make sure that I'm not doing any short, so this should be connected to this. So again, using magnet to catch it. Put everything straight as much as you can. Be careful that the magnet will not do any short for you. Okay, so now only two last cells. Up. Okay, so we now can put it like this and continue. So last two cells minus to the plus of the second. And now again cut the piece for the correct length, the nickel strip, make sure that you are not shorting, so do it always double check and use the magnet. Okay. Okay, very nice. So now our pack is not ready, of course, but we need the parallel at the end to connect between them, and later we can connect everything with a Kapton tape. Maybe we can do it now. So let's put a Kapton tape to hold everything together. Okay, so searching for a nickel strip that will do the job. Okay, I have to cut another piece. Oh, did you see this? So need to be careful and maybe reduce the number when the capacitor fully charged, so the pulse is quite strong. And by the way, if you put it very strong, so you will have less sparks out and more energy will go to the welding. So again, searching for magnet. Now we are done with this pack and we can continue. So I like to use this active balancing module. It's not very accurate, but it's good enough. It will give you less than, I think, 100 millivolts, maybe less, even less than 50. You can balance it better, but this will be good enough for most application. So first we need to connect its cable from the minus and then go all the connection and connect it. So this is how to connect the BMS itself. We have the battery minus, which is connected to the minus of the battery plus. I am adding always a fuse to be on the safe side. If everything burns, the fuse will protect, so it should be before connecting the BMS to the battery and not at the outside of the BMS. And then we have the B1, B2 and B3, which are going after cell number 1, cell number 2 and cell number 3, and the P minus and P plus is the output of this battery pack. Don't forget to put a Kapton tape beneath this board, and I adding an extra isolation before connecting it to the battery to be on the safe side, and also wrapping everything in Kapton before closing the pack itself. Okay, what I wanted to show is that you can always do balancing using device like this. This is the ISDT BG8S that allow to do cell balance up to 8 cells. So you can use it, and it gives you the ability to show the percentage of all the battery, 85%, and currently 47 millivolt is the balancing situation, and when it will be finished, so all the cells will be balanced much better. So I will give it to work, and then the last step will be to connect the BMS PCB. So let's wait for the balancing process to complete. So after almost 4 hours we have the cell balance, 4 millivolt difference. This is more good than needed. Okay, so we have a very good balance, and we are going to the next steps. So now I will disconnect everything and connect the BMS. So next step is to wrap these batteries with Kapton. Okay. Okay, now I will want to connect all the BMS one by one. So it goes like this. First I will glue it here like this with a hot glue, and then we'll connect everything together. Okay, now I want to be able to remove the fuse, so I will put it Now I have the B1. The B1 will go after the first cell, so I can shorten it, the wire, to get exactly to the correct position here. Okay, mistake, my mistake, the B1 is the other side, of course, because I'm counting from the minus to the plus. So this is the wrong connection for the B1. Okay, so make sure to connect it in the correct order. So we'll connect it now to the other side where it should be. So don't forget, it's always good to start from the minus. So now let's connect the minus also. So the minus is going to this way here. Be careful with your iron and solder not to short anything. If it doesn't look good to you, so add more solder till you're satisfied with the result. So adding more solder, fluttering the wire here. Now it's okay. So now we have the B1. The B1 is going beneath the first cell, so it will be here. Avoid metal parts while working with the battery. Of course, in order not to short anything. So B2 will be here on the top. Okay, B3 will be, this is B1, B2, this will be B3. Now usually at this stage, it depends on the BMS, the battery will not apply a voltage out. If this is the case, so I will show you what to do. You just need to charge it for a second and then everything will be okay. Like this, you see there is no voltage out. So what you need to do in this case, maybe I will take this wire beneath the big wire, it will be better, I think. So if this is your case, we have no voltage, it's very simple, just apply a charge and then it will start to work. I'm using a power supply or the chargers that you want to use in this case. Put 16 volt 1 amp and just 1 second and it should solve the problem. Now it should be okay. Let's check. Yes, we have voltage out. So now your battery pack is ready. Of course there are a few more steps in order to close everything together. I will show you. You want, of course, maybe to apply more Kapton tape on the top to avoid shorts and that everything will be fixed in its place, something like this. Now the last thing that I use, I will show you in a minute. Just I want to mark where the fuse is going to. The battery, nice. Okay, so I will need to cut a part of this heat shrink and then we'll use it. So first you can take your fuse out in order to see it, and you can glue it with super glue and then shrink it. So maybe I will do it. So just close one side with a heat shrink, or you can do without, just apply heat and everything will be okay. Because it is too big, so I need to cut it here also. So something like this, and then I will be able to close everything. So first I will use some hot glue and then we'll fix everything together. Now just applying heat to the heat shrink. So this is while lighting. Everything is working and the battery is here. That's all. Thank you and bye.